you very much for having me here. I just wonder about the state of the ecosystem. So if you can help me raising your hand if you are working with hardware, on hardware, even if it's not with nerves. Somebody working? Nice. And with nerves in production, somebody, okay? And just one more. Is somebody here deploying Elixir in Amazon without a managed layer, without Heroku or something? No? Nobody? Okay, well. My name is Alfonso, but almost everybody call me Fons. Actually, you can find me almost everywhere on the internet as Fons. I've been in the software development environment for more than 10 years. And for the past 6 years, I've been working with Elixir. Even if was focused on web development, before the software engineering, I made a technical career in electronics. But I thought I never would touch one more board in my life. But 3 years ago, I joined Intuitivo, that is the company that is reinventing the retail 3.0 through the APOPs. So I want to share how was the journey building this product. And first of all, I want to show you what was the main idea. So we had the dream to build some way so that people can go and buy whatever they want, whenever they want, and wherever they want. So that requires an unattended point of purchase. So we thought that we need to build some bridge between the smartphones of the people and some point of purchase. So we imagine something like that. So I'm going to split in 3 steps this talk in order to focus, first of all, in the idea and what we try to do at the beginning. So first of all, we had business requirements and tech requirements. So we wanted to know more about the customer, so we needed to know who was buying. We needed to add payment methods so we can charge at some point. We needed on-site operation because it's unattended, but we need to do something in the place. And we want to make the experience of go to some place and get a product and just go out and be in charge after some minutes. So that required, in the technical side, running in a low-cost device, having integrations with a wallet. So we needed to find a way to make that financial process. Of course, we wanted to do it through the smartphone, so it's something that all of us have in the pocket. We needed to collect data inside so we can send it to the cloud, process with some algorithms, and then make the transaction inference and make the charge. So early in the project, as we were mainly web development backgrounds, we started making some combinations. I have to say that there were like several iterations of ideas and tries of different technologies. So at some point, we were working with Raspberry, Arduino, so we can get analog signals and then pass it to digital systems. And we were just running web servers in order to understand what was happening in the transaction. So at the beginning, we just needed to send some data to the cloud, but we wanted to do it like in real time because we want to make a fast charge. So we ended up having a WebSockets API gateway in the cloud. So we just send through the WebSockets with a really simple client to the cloud. As it's an unattended point of purchase, we needed to make it sort of recoverable or independent. So if it crashes, if it just has like a network or power outage, it could like restart after some time. So we just added like a simple Linux service, understanding that that's the way like some software is running in our OS. And we needed to upgrade remotely, because at that point, the COVID emergency started. So we weren't able to go to the places and make upgrades and make maintenance. So we decided just to find a really simple way to upgrade. And we got a first version in production. Actually, we sent this to the wild, and this is a video in an Argentinian mall, where it's actually a real video, where it's just working all the system with a smartphone, getting data, sending it to the cloud, and then through computer vision and some machine learning models, we were able to process the transactions and make a charge after inference of the ticket. So if you see, you can think that it's like a really like simplistic solution without going deep. But we just wanted to validate and see what was happening with the product. And then we started to improve some parts of the system and understand what was going on with the product. So just thinking about the solution, we were with a lot of issues. But we tried to tackle the most important issues in the list. So first, the ARMs are not really powerful against a conventional computer, so we needed to improve that part. Our devices were starting so slow, so for that reason, we needed to find a way to start all our software faster, to improve the communication so we can send more data and faster and receive the data inside our devices. As the implementation for the remote upgrade was really simple, it was like very easy to corrupt the data and just break the devices. So we needed to completely replace that part. And something that was very focused on the hardware side was that we decided at some point that we needed to capture image with cameras in the place, so we can process that with computer vision. But what we didn't thought was that as we advanced in the process of the transactions, we were needing to improve the quality of the image so we can train better models. And we tried it. We started just to modify the params. And at some point, we understood that when you have more than 2 USB ports in the same PCI, you won't have enough bandwidth. And at the same time, if you are trying to increase the quality of what you are getting from some devices out of your ARM, you need more power. You need more current. So, well, at the same point, I'm not sure if I'm wrong, but I think in 2021, it was LiveView 0.17, and we just decided to make a POC of how we'll be like having a LiveView dashboard. So we ended up making a good test about using the WebSockets. And what we found was that it was really easy to implement the sockets. It was really easy to get real-time data. So by one hand, we were like excited about using Phoenix, and by the other side, we were tackling how to solve our issues. So in the first step, what we saw inside the device is that we weren't using all the cores. We were using just one core because of the way we were writing the software. So we tried PM2, that it's a library for Node that it's capable to watch the cores and try to use them. But concurrency is not that easy. It's not that easy if you don't have the right tools or if you don't have like some experience building concurrency with a monothread language. So it was not really a solution, but it helped to make it better. At that time, we were recording video with 3 different cameras. As I said, it was not possible to have that bandwidth in just one board, so we decided to split the solution and have a second board in order to control one camera and have enough bandwidth, and that increases the current that you need, so you need to change your power supply, okay? But we understood that at that time. But we needed to add communication between the boards, so that make us to write more code to communicate. And we needed to synchronize the video because we were receiving messages from the server to start the recording in 2 different devices, but we needed to start at the same time and synchronize all the video. So at some point, we tried to improve how fast was the software running. And we added like a rusty version. This is just a like summary how it was working, trying to start up faster the software, trying to not corrupt the files, trying to capture video with lower memory usage. But it was not really easy at that moment. So we just kept the software and tried to build solutions around the software. At the same time, we still had the constraints about having a low-cost device and making everything remote. We were not able to live out of the office and going to the points, so we needed to make everything remote. So as we were advancing with Phoenix channels, and LiveView, we decided to watch about nerves. And it was really interesting how accessible it was to make a POC in the top of nerves. At the same time, we found Nerves Hub. ElixirConf, it's like a server, pre-built server where you can just mount your firmware versions and just distribute everything to your devices so you can deploy easy with this server. But as we are just exploring nerves, what we decided is just to move our solution that was running in the top of an API gateway to our Phoenix WebSocket solution, running in Phoenix. So what we found in ElixirConf were some suggestions of how to implement the code, talking about the WebSockets. So we ended up using Slipstream, that it's not really for embedded device. It's just like a library inside the Elixir ecosystem that you can use in servers, or in this case, we are using it to communicate the devices to the server. So we decided that we could continue building our solution using Nerves, Elixir, and Phoenix. That was really nice. It was like a relief to see that we were using, through the beam inside the Nerves, all the cores, and we were using less memory. We were like more aware about our peripheral devices. So that was nice. But at the end, we needed to record video. So we explored how to do it inside Nerves, and what we found is that Nerves is in the top of Buildroot. Buildroot, it's a small Linux distribution for embedded devices, and it's not by default GStreamer inside Buildroot. So just talking with the community, somebody said, okay, you need to build a custom system. And being honest, at that moment I saw Buildroot and I didn't understand anything. So for that reason, we tried different options. So one condition or one constraint that we had at that moment, it was that we were recording video or encoding video with OMX. At the same time, Nerves was migrated to 64 bits. And exactly in that difference between kernels, OMX was completely disabled. So one other option that we explored was Membrane, that it's a full tool set for media servers, streaming, capturing video, audio. But I think was like a huge overkill for our Nerves device at that moment. So we needed to step back and going back to PyOS, or the evolution of Raspbian, and mount Elixir in the top of that. So we just built mixed releases in the top of PyOS, and we started to run again in the top of Raspberry OS, but with the power of Elixir. At the same time, what we tried was to run GeoStreamer with the version that we needed inside a Docker image. And it was really fun to implement that. I'm going to show you how the partitions are built in an SD card inside Nerves. But you have a data partition where you can write. So in that partition, we mounted Docker. So we were calling Docker from Nerves to start a GStreaming process inside a Docker image. It was really like an overkill for the hardware, but we tried, and it was fun. We ran Nix as well. It was good, but was not our expertise to do it. So if you see, this is a way we still right now could run Docker inside nerves, just a system call. But at the end of what we like it and we are using right now, it's through Moontrap. Moontrap is a library where you can spawn processes and get the PID and then have all the feedback about that process. So you can launch syscalls and have all the information of what is happening with that OS process. So at the end, exploring everything and making it work, even if it's through Docker, we were able to build a real-time dashboard, getting all the real-time data from Phoenix channels, nerves, and all the telemetry that we could have from all these devices. So at that time, we were able to improve the time to response for all the devices and know kind of real-time everything about the device. So going to the most interesting part. At this moment, we were just using what all the ecosystem was providing to us to improve our work. But we still need to continue building features for our product and continue following some guidance. So first of all, we were already recording video in a proper way, but we need to improve what we were providing to the AI. We needed to increase the frames per second. We need to increase the quality of the video, and we need to do everything faster because we are just taking some seconds to process all the transaction and send the charge to your wallet. So this took us back to that message about the custom system. And we needed to go and learn Buildroot. Thankfully, we have an amazing team that had the time to learn and understand how is Buildroot built and how to improve everything inside the Buildroot. So basically, you have a menu where you have packages, you have different platforms. You just need to select your packages. And actually, you can find drivers. You have search. So it's just sort of reading the manual and understanding what you're doing. And at the end, it's just like configs. So at some point, we understood that we were able to change the kernel as well. So we understood that we could change the kernel inside Buildroot and then just check about the flags, the difference between the version of the kernel in Linux, especially in Raspbian, that it's the OS designed for Raspberry. And we were with a brand new box. We had an actual firmware that were not writable, not just read-only. We were recording in high quality, high frames per second, and we were encoding in a different way and with more power inside the ARM, using the GPU. And now, that was the base to us to allow us to right now have a custom design of our board and having all the devices that we need in our custom ARM. So as our partners are mostly enterprise, we need to cover some requirements, legal requirements, IT security requirements. So for that reason, it was working our way to upgrade our firmware, but we needed to be safer. So for that reason, we started to integrate Amazon Greengrass. So basically, you have two parts: IoT Core, that it's like a management of the devices inside AWS, and you have Greengrass, that it's all the sets, daemons, and scripts for your devices. So basically, inside the console of Amazon, you have some terminology. You have a thing that it's a device. You can group things. Then you have a core device that it's almost the same that a thing, but it's just a link between ID in the core and ID in the device. And then you have deployments, that it's something like some workflows that launch the updates for your firmware. So our requirements were have some sort of authentication, validate that it's some of our devices, check for the artifacts that are new versions for the firmware, download it, install it, run it, switch the version, and as possible, keep it safe. And I say as possible because you can always break something, but we are also including encryption for some parts of the communications between the devices and the core. We have some process where when we validate that it's one of our devices who is trying to connect with our server, we make a handshake and then create some certificates, and we provide secure connections through those certs. So this is how you see devices inside the Amazon console. What it's really nice inside there is that you can, if you see in the bottom of the screen, you can launch a huge amount of upgrades to all your devices by group or by different params, and you can see if the device is already upgraded or is like waiting for some update or probably is not receiving the update properly. We have an amazing infrastructure team that it's working behind the scenes. So even if you can do it like manually inside the console of Amazon, all this stuff of configure your devices and send the deployments, we have like almost everything automated behind our dashboard. And our team, it's like building the firmware in the cloud. So we just push code to the repo. We make some workflow of authorize the version. And the cloud builds the firmware and then dispatch everything to all our devices. So basically, you have, in terms of infrastructure, components that it's like a combination of configs and logic to send all the upgrades to your devices. So it's a simple YAML receipt where you define the names of your firmware. You send like the IDs to make the difference between versions. And if you see in the line of script, we are just talking with firmware up in order to receive the new version and launch this process where switch the partition to start with the new version. And if you see, you have something like cool stuff like skip. If the device already have the version, won't do anything. So we needed to do that, but we didn't really find the way to change the partitions of nerves. Thankfully, the community is always active. We talk with friends, and This we just learned that we needed to build some configuration in the top of firmware up, and we just decide the size of the partitions, the type of the partitions. So this is how it's look like the SD card inside. Normally you have the U-boot, like it's the booter, and you have two partitions, two versions of the firmware with the booter, and you have data, where you can write data. But we just added another partition, having Greengrass, having a home directory for the user. And inside the firmware up configuration, we just, during the building in the cloud, we just get the Java file, the Java daemon of Greengrass, and put it inside the build. And we just start the daemon with this configuration in firmware up. So inside nerves, you just need to tell to your application that you need to start another partition as well. We just build a different runtime and different wizards like VintageNet to configure our Wi-Fi to run these daemons just in order to customize our system. And we just have like gen servers to understand what is happening. This is just like a summary of how we listen if it's downloading a new package from the Amazon artifacts. And if it's a new update available, we just launch the firmware up option to restart. So finally, we are experimenting with private 5G. We are isolating our devices so we don't need to go through a Wi-Fi or a public network, because we need to separate the load of the network. And this is the part where we say we did it. We built it because the reason we need to isolate our devices is because when you are in a crowded place, like in a stadium, you cannot offer that amount of people trying to go into the network. So if you're near Miami, you can go to the Marlins Stadium and try our technology, where we are running in real time through our private 5G. So that's the way we are mixing all these worlds of beam clusters, beam state, and all that cool stuff that we will need another talk to explain everything. So at the end, we did it because we can support millions of devices, real time. We can do everything remotely. And now we have a set of products that are like changing the way the retail will work in the future. So we have wallet, we have real-time stats, we have our devices upgrades. It's safe. We are making inference all the time about the transactions and retraining our models with every transaction that it's coming in real time. So what we can share with you about our links, most of you could say that this is like normal, that everybody should know it. But just to share, think about your strategies. It's different, replace and migrate. Sometimes it will take more and more time trying to migrate versus just replace something. If you are working with hardware, bring to your team hardware experts, because it's not easy. Learn about your stack. We had a lot of free stuff when we started to learn about Phoenix channels and all the libraries. When you're building a product, measure, collect data so you can understand if you are doing well, if you need to improve something, or if you don't really need to take care about something in your technology. And by the other side, train your team. I made the mistake to not have the same training to all the team in order to have the same concepts in the mind to understand how Elixir and the ecosystem is working. Hardware is not easy, but nerves is really accessible. It's really nice to not having knowledge about ARMs and just go and build your project because you know Elixir. Choose your tools, trust the expertise of the companies that are already been for decades working with these tools. And the most important, get and give support to the community. If you see, through the Slack channel, we had a lot of help, so we just solved a lot of stuff just talking with the community. So thank you very much. I'm Alfonso Gonzalez. You can find me as Fons everywhere. You can find more about our technology in intuitivo.com. And we have some positions, but we are always looking for amazing people if you want to join us. So thanks.